fantastic. I don't know if Dick will respond. Technical. One of the big concerns is moisture in the layer. And if I'm correct, plastic has a kind of a, or polymers have a sort of a porosity to moisture. So although the initial sample could be dried out, I'm wondering if over time there could be some sort of absorption of moisture so that you would need to seal the unit with a metal or something to prevent moisture.
Dick, over to you.
Here's a good question.
Hear me?
Epoxy is hydrophilic. You'll accept moisture. And that's why you saw that we actually showed data where we dried it out. You saw the dramatic increase in installation resistance due to that. With that, we can stack that inside of a dry box. Now, we call it environmental chamber. You saw the one we built on our last resort. I'm proud of it. Built that in 5 weeks. And so it's this. Once we dry it out, we keep it in a dry environment, like 5% relative humidity, and we stack that thing in there. And then we injected mold a hydrophobic material, which is polypropylene, and that then rejects water. But that's not good enough. We're going to then seal this thing with a proprietary solution that we have that turns it into super hydrophobic. You throw that thing in the ocean, come back later, there's not going to be water in it. It's already been tested for 25 years of water rejection. So yes, we will take very distinct technical steps to make sure this thing, that no water ever goes into, within the reasons of the tests we've had. Does that answer your question?
That's good. I actually have two more.
Yeah, shoot away.
Okay. Now, in the process of drying, you use a vapor compression to reduce moisture out of the air. I'm actually familiar with research, or somewhat familiar, involved in research using desiccants. And just wondering if you foresee a possibility of using desiccants in the drying process. In particular, I'm with Queens. We use a desiccant system that can be regenerated quite cost effectively.
Well, what we found to be very effective and very quick is we put the thing into a environmental chamber at a temperature under 27 inches of mercury, and that thing dries out in a very quick time. I mean, we actually draw that moisture out of the epoxy very effectively. Well, you can see it by the resistance that we're getting.
Yeah.
So it's cost effective, it's quick, and we keep it under control inside of a dry box.
Okay, super. Third and last question.
Go ahead.
Okay. Having packaged everything, do you see any kind of thermal issues, like potential thermal issues in the packaging, sealed packaging?
Here's the nice thing about it. Our composition modified barium titanate powders, when we certified it, we tested them from minus 40 degrees C up to 85 degrees C. It was flat. In fact, it grew as we go out there. Now, the epoxies that we're using, we actually cure that thing at 120 degrees C. I don't think you're going to see that thing unless it's in a deep space. So we have a very high control of thermal capability of our part.
So even if you're charging at a very high rate,
that's more.
It's true, I'm sorry. Okay. How often do I get a chance to ask all these questions?
Sit down and come back again. Sit down and ask the question again.
Okay. So even at a very high current, a very high charge rate, you don't see issues with any kind of thermal dissipation.
Mm-hmm. Well, here's the nice part about our part on thermal and rapid charging of it. We actually charge that thing in less than a second. In fact, when we did the testing at Intertech, that was a 6-second charge. If you do that to aluminum electronic parts, you're going to blow that thing.
Yeah.
So one of the many features we have with this technology been designed into it is rapid charge.
Yeah.
I've actually, in the military, I arc charged it, I sparked it up, and then sparked it down, they were still working. So that's another great feature of our technology, the many that we have, is rapid charge and rapid discharge. It's a plastic. It's immersed into this plastic. It's a composition modified that you're actually not taking. Here's the nice thing now. This is important now. We don't take current in or out of this product. What we do is we rotate crystallites. There's no current goes into this thing. In fact, at 20 gigohms, it's not a driving current no matter what you do. 20 gigohms, 20 times 10 to the 9th ohms. And so really it is designed to be a very rugged part from a fast charge, fast discharge, which gives us another big advantage in the market applications that we're looking for.
Thanks very much, Dave.
Thank you very much.
We'll take this gentleman here. Go right ahead.
We're not going from that? Yeah, that's me. Brian Kelly, and I've got a couple questions, mostly focused on the Intertech report. One's about strategy and one's about technology. The first one is about strategy. It looks like we are, the report is purposely leaving out data. The first Intertech report made a comment about, and I think that's a good thing. Don't get me wrong, but I kind of want a confirmation on that we're talking about. But it says something about as you stack the layers, they don't add up as expected. They actually add up. The capacitance is greater than expected, but there was no supporting data there, so that led me to think that there was some more to the Intertech report that we didn't see. And so that's my question. And are we withholding that because we don't want to, it adds value to the potential JV for, this is, I guess, yes, strategy would be for Mr. Clifford. So does that add value to the potential JV if they are buying something that their competitors don't know exactly how good it is?
Okay, Mr. Gully, we'll have Ian answer.
Yeah, the simple answer to that question is really to focus on who the joint venture partner is and what their operating requirements are for the technology. Part of what will be happening in these initial discussions will be a definition of requirement, a specification of requirement from the partners. And we've had these discussions. We have some understanding within various markets what the requirements are. So our starting point there will be to build then production prototype parts to meet those objectives, those specifications. So we can't, at this point within the Intertech testing, we're not building specification parts for any particular partner. What we're doing is demonstrating broad application, broad ability of the technology, but we're not honing in on the specific needs yet of the particular partnerships. So the testing at Intertech at this point is not partner specific, if you will. It's much broader than that at this point. So you will see as we progress in these discussions and in further prototyping, you will see further refinement of the technology that we will then test and publicize as well, to the extent that we can, depending on who the partner is.
Mr. Kelly, before you ask your next question, we have a question from the webcast, and that question was, what happened to the 2008 patent EESU? And the answer is we still haven't. It hasn't gone away. So now, Mr. Kelly, you have a second question?
Yeah, the second question about the reports, and this is for Mr. Weir. It's kind of a technical question. Is the capacitance that we're measuring, I'll call it an apparent capacitance because it's maybe a product property of some of the, piezoelectric and magneto-coupled as well as electronic coming out. And so that's a question. But then in the report, they have a hypothesis that they're doing, and this is what leads me to that belief, is that instead of saying we're going to measure the capacitance, we're going to measure the DF, they say we have a hypothesis that capacitance can be measured and is repeatable. And we have a hypothesis that, and so the conclusion of the report was yes, it's repeatable, it's measurable, and that seems like an interesting conclusion to make that we should have been making. The capacitance, for this part for sure, but in general, capacitors, whether the capacitance is repeatable and is something that's been known for years. So I guess why is that title there, and is it the emergent properties that's driving that?
Well, we're a high voltage capacitor, so we have to measure these capacitance at these voltages. Easter developed a very unique technique, which was we had a doctor from University of Texas come in and validate and said, well, that thing's within sub nanofarad range, which is fantastic. But see, we have to look at that under voltage. And I invented a way where we can do that on a time constant, very accurately, highly measure the resistance that is going through the RC time constant, and with that we can give the capacitance a number at either 500 volts, 750 volts, up to 2,500 volts. We've tested things in our park about that. So at that we have to give a capacity at that number. And we've done that. Now, like Ian says, we invited Intertech down. We didn't lead the audience here. We showed them what we did. They went off and designed their own system. And their number was at 1% of our number. Again, another series of validations. So this is why we've done what we've done. Now, if you want to know the equivalent series resistance or dissipation factor, we use a state-of-the-art LCR or system built by Hewlett-Packard. It's been around for a long time. And that will measure at 1 volt, though, what the equivalent series resistance is and what the dissipation factor is, which is a pure factor number for us, so we can relate that to the industry. So all those are very accurate.
Thanks so much.
Thank you very much, sir.
Hey, thank you.
I have a question from the webcast, and this will be for Ian. Why are we talking about capacitors and not energy storage for vehicles?
We're talking about both, actually, to answer the question. The ultimate objective for the company has not changed. High energy density, solid state energy density, energy storage is still I guess our guiding vision and our ultimate objective. The reason we are undertaking this advanced polymer work is specifically to look at various solutions that will help us, utilizing DIC's CMBT, work towards higher energy densities that are stable, that are inexpensive, and that are scalable. These are still very much objectives. But on May 18th of last year, we made the decision that we needed to set some foundational discovery of where the technology was based on DIC's extensive work utilizing the epoxy polymers that he had done so much work on. So DIC really focused heavily in that 6-month period, as I mentioned in my presentation, on developing the best and most versatile capacitor technology that we could achieve at that given point.
Thank you.
My name is Eric Manell, and I'm at the microphone in part because I was concerned that Greg Gooch was going to take the microphone. Some people might know what I'm talking about. The question I have for the panel is, yes, exactly. How often do you talk to Lockheed?
Good question. How often do you talk to Lockheed?
How often do we talk to Lockheed? In the year that I've been sitting in this current position, I've had 3 conversations with Lockheed specifically around this, and we can't at this point talk about what we're doing with them, but they are, as I said in my presentation, of great interest to us. I'm sorry, sir?
We have a relationship with Lockheed. It's a strong relationship, has been for many years. I think what he's saying is very true. But we have to go out and take advantage of what we've done in the past to move forward. And I can't talk about Lockheed right now. I don't want to talk about Lockheed right now. All I can say is they're a good company, and we sure as hell would love to have them and keep them on our side, which I think we'll do.
We want to inculcate the relationship of those partnerships or associations or relationships that eStore has, and we're not letting them go as we go forward and looking for strategic partners. The only issue is when we talk to them and how often we talk to them. I'm sorry, go ahead.
Hi, my name is Brian Kirk. I just had a quick question for Ian. How long does Dennis think it'll take to actually do a joint venture from the time some of these firms walk in the door to the time that they exit? Because it seems to me that there's obviously going to be a lot of firms coming in and out. A deal like that doesn't happen overnight. And if everything is what we hope it is, you guys are going to get steamrolled by so many people coming at you. How do you anticipate handling this? And what is the most important thing within that JV that you want to see done? Is it doing it quickly? Is it getting money up front? What's the most important factor of that joint venture, or potential joint venture?
Right. Yeah, no, it's a very good question, Brian. Thank you. I decided that I would not be specific in terms of timeframes. I can only repeat what Dennis has said publicly in that regard, and that is that the most strategic partners that we will find will move extremely quickly on the opportunity. There is not a lot of disruptive technology within this industry, as we have learned, and if we represent disruption to any of these key partners, they will act as quickly as they can to really to get a priority access to what it is that we have. And that could happen a number of different ways. I mean, you talked about a downstroke payment to secure a negotiation in a particular vertical. That's a possibility. We have a lot of interest in terms of partners who can move this technology into multiple vertical markets. The broader the scope, the more opportunity there is for us. We also want partners who have manufacturing capabilities, who understand how DIC works with the materials and produces the layers and stacks and so on, who will be quick adopters of that. So I know that's not a specific answer, but we will be working as fast as the partners are willing to work with us, and we expect that these will be rapid discussions, and we'll get things moving as quickly as we can.
Gotcha. Is there like for your short-term financing needs, is there any sort of a plan there if this JV negotiation takes longer? Because everybody that I talk to from an investment standpoint is saying, call me when the JV happens.
Yeah.
And that is the elephant in the room.
Right.
And if this stretches out 6 months, where are we at?
Right. And no, it's a perfectly fair question, and we're looking at every alternative we can in terms of financing right now, and understanding that the trigger for many is that joint venture partnership announcement, but we have no control over the time of that. So, as I said, we need to make sure that we have a strong financial position going forward, and we will do whatever is necessary to ensure that.
And none of those potential partners outside of Dennis's contacts will make any sort of comment at this point as to their interest in the technology, or like, I mean,
I hear what you're saying.
Yeah, I know you can't. I know you guys can't say Lockheed Martin, but it's like if you said XYZ and eStore, it would be like.
No, but
it would be huge.
Yes. Well, let me put it this way. I mean, it was last Thursday that we announced Phase 2, right? And that moved, Dennis's level of confidence up significantly. We will now entertain those relationships as well as the previous relationships that eStore has. We're at a point of readiness for those discussions, and we will announce them as quick as we can. As I said, that'll be opportunity specific. We can't at this point. I can't suggest that it'll be 2 weeks from now that we announce our first joint venture. However, it will be as soon as we possibly can with the partners.
Okay.
Thanks.
Question from
Dick.
Okay. I have a question for Dick from the webcast. Dick, how do you know what the energy storage limits are for your technology?
It's built on one thing, it's the relative permittivity. The higher I get the relative permittivity, the energy storage goes up. So what we're pushing now, and have been for 5 years, is, like Ian says, looking at polymers that gives us higher and higher polarity. Polarity relates to higher permittivity. So what's the limit of our capabilities is going to be the voltage breakdown of the materials that I put in there. Well, the materials I'm putting in there have 600 volts per micron capability. So I don't think we're you'll hit other limits before you do that, and that's usually just how far can you take the permittivity up. So the limiting factor will be one, if it's ready to, is how far I can take polarity of the system. And when I do that, then permittivity goes up, and then we're in that whole rise right now of investigation.
Thank you. Sir?
Hi, my name is Keith Pope. I've been a shareholder since 2008. Just a quick question about this last Phase 2 report, and where it was also where Dennis was said that the markets, there was more opportunity, perhaps maybe up to 20 more companies or capacity companies that would be that he could be targeting. So just the question is, up to this point, we've been pretty much just high voltage, utility, power, conditioning type capacitors, and the volumetrics associated with that. Is the latest results showing that we've got a broader scope in terms of the capacitor markets? And I refer specifically to Dennis's remarks in his original report about medical devices. And given the volumetrics, obviously, are significantly different for the capacitance. So I'm just curious where we are in terms of broadening the scope beyond utility power conditioning.
Ian, you want to take that?
Yeah, no, well, as Dick mentioned, I mean, we differentiate at high voltages, clearly. I mean, there's lots of low voltage capacitors that are commodity type devices that are of less interest to us today, obviously. Our focus is very much on higher voltage, more specialized opportunities with the technology. So that's our initial focus. At this point, I can't say where it will go and how broad our markets will be, but we have to focus in today on where, as Stuart says, the lowest hanging fruit for the organization is going to be those immediate markets that we can address with the technology where it is today.
Just a supplemental. So, but you're still in the, and I'll use the term, a mode of being able to do a dial-a-cap to specific capacitance and volume.
Absolutely, and I mean the Phase 1, as I said earlier, the Phase 1 report from Intertek was really a foundational report. It was to show the versatility of the material across multiple voltages and various potential applications, I should say. Because we were only at that point dealing with single layers, except at the lower 250 volt stacked component. Moving to Phase 2 with a 750 volt stacked part is a very significant move for us, and to Dick's point, proves capability within a higher voltage application, which is really, really where we have the most strength today.
Todd Daniels from the webcast has asked a question, which I'll direct to you, Ian, and that is, so what is Phase 3?
Phase 3 is what we get to next, because we just did Phase 2, so Phase 3 is the next.
Got it.
Right.
Tell
I mean, likely, you saw our program over the next 6 months. Phase 3, our expectation, and Dick, you can correct me if I'm wrong, but I don't think I am, is looking very much at the robotics, so stacking an order of magnitude more layers within a robotic assembly application. So that's we're going to be heavily focused on that.
And also continue looking at advanced polymers.
Yeah.
I really feel that we need to meet the present requirements. So I think you're seeing the results of our releases. But equally important, we have to say, where do we go in the future? We're working on the future. Don't worry, guys. We're working on it.
Yeah. Thank you, Dick.
Ken Holden, stockholder since 2008. And my comments are more of a suggestion as opposed to a question. The nature of eStore's product is highly technical, and it also is really not readily understood by the common investor. In order for us to have a higher share price to improve our negotiating position, I'd really like to suggest that there will be other comments other than just the comments that could be understood by the capacitor manufacturers.
Right.
The ZENN AGM down in the United States does not really have a huge high volume. So as a result, small purchases have a dramatic impact.
Right.
And those dramatic impacts still move our share price, and there's an interrelationship between the two. And that's just one of the things I'd like to see is maybe Mr. Zogby or whoever else is going to do the announcements have a comparison more or less, something that the average investor can understand. I think that would help the analysts and also the people that are putting pressure on these cat manufacturers. Many of them are publicly owned as well, and they could be subject to pressure.
Yeah.
But it's just a suggestion that I think would help our share price.
Yeah, no, very good suggestion. I think that when we get to the stage of announcing partnerships, we'll be talking very specifically about opportunity within those partnerships. So what markets are being targeted specifically by our partners with our technology, and then any analyst at that point can do a much more accurate evaluation of the potential value. It comes with more and more clarity in terms of market opportunity. And then the other thing in terms of the effect that the small pink sheet market has on the stock in the States, another reason we want to look seriously at the appropriate time to list in the U.S. so that we have a lot of shareholders in the U.S. who are somewhat they're almost ostracized from the story because they're trading in a market that we have no involvement in. I mean, the pink sheets that's an independent process. ZENN eStore Corporation has no access to or involvement in that market. It would be much more appropriate at the right time for us to be listed in the U.S., and we will look at that seriously.
Are there any more questions? We have none from the webcast. One more? Mr. Kelly?
Hey, you can repeat the question. No, that's okay. Very good question. And let me tell you, our next phase is not only restacking the stuff, and see, like I was telling this one gentleman about sealing the part. And then my world is coming from very high product certification and testing from the military. It had a huge military. And we're going to go down that path. And Intertech, by the way, knows the path very well. But we're going to do it in our house first. And so the next phase is not only to stack it, get it done, get it sealed, build it effectively from a production base, and get that thing certified by the very tough military regulated product testing. And then that publication will not be published until Intertech certifies it the same way. And they're very well knowledgeable about that test. Does that answer your question, sir? Thank you very much.
Thank you very much for attending, and we're going to be here for, I'd say maybe 10 or 15 more minutes. So if you want to swarm Dick or Tom or Greg or Ian, feel free, but we'll be here for about 15 more minutes. Thank you again.